Good morning. Here's math project number 20. First, a practice problem. You spent $1, and I guess I mean exactly $1, for some 5-cent toys and some 11-cent toys. How many 11-cent toys did you buy? Okay. So, do you understand the problem?
Yep.
How much money did you spend?
$1.
Exactly $1.
Yeah, on the dot.
How many 5-cent toys did you buy?
We don't know. It just said some.
We don't know. How many 11-cent toys did you buy?
We don't know.
We don't know.
So we can call them X and Y.
Yeah, X and Y, how about? And how many, we're trying to figure out how many 11-cent toys do you buy. So we got 5X plus 11Y equals how much? How much did you spend in cents?
100 cents.
100 cents. Now, normally you wouldn't think you could solve a problem like this because you have two unknowns. But in this case, you actually can. This is a special kind of problem where you can solve this. So let's try to figure out why you can solve this, first of all. What do you know that's special about multiples of 5?
Well, they end in a 5 with a 0.
They end in a 5 or a 0. What does 100 end in?
A 0.
A 0. So multiples of 5 end in a 5 or a 0, and this over here ends in a 5 or ends in a 0.
So this is 5 times. So 100 is 5 times 20.
Well, right, but we bought some 11-cent toys too. So we could buy 20. We could buy 20 5-cent toys and get to $1 and buy 0 11-cent toys. But it says we bought some 11-cent toys too. So we have to figure out different. So if this ends in a 5, and since this ends in a 0, what will this have to end in?
Has to end in a 5 or 0.
No. If this ends in a 5, 5 plus what will end in a 0?
5 plus 5.
5 plus 5. So if this one ends in a 5,
then that 11 thing has to
end in a 5. And what if it ends in a 0?
It's not going to work. If it ends in a 0, then it's not going to work.
Well, let's see. 0 plus what ends in a 0?
0 plus 0.
0 plus 0. So what we're going to have to try to find is some multiple of 11 that ends in a 5 or ends in a 0.
55.
Okay. So let's see.
55 is one of them.
55 is one of them. So hold on one second. So multiple of 11 that ends in 0 or 5. So 11 times 1, 2, 3, 4, 5, 6, 7, 8, and 9.
Well, we know that 5 is one of them.
Well, what's 11 times 1?
11. That really doesn't work.
What's 11 times 2?
22.
22. What's 11 times 3?
33.
What's 11 times 4?
44.
44. What's 11 times 5?
55.
55.
That works.
What's 11 times 6?
66.
What's 11 times 7?
77.
What's 11 times 8?
88.
What's 11 times 9?
99.
Okay. Do any of those end in 5 or 0?
Only the 5.
Only the 5 ends in. Okay. So if we bought 5 11-cent.
And that means we bought 15. That means we bought 15 5-cent toys.
Well, wait. How did you figure that out?
Well, because originally we had $1 and
Right, we had $1, and how much did we spend on the 11 cents?
55
Okay.
cents.
All right.
So let's see. So we got 55 cents spent, and now, well, let's see. So we have 10 more to go if we had 50.
Right.
And we had 10 5 cents. Let's see. And so we have 55, so there's going to be 9.
Okay, so how much more do you have to go? What's 100 minus 55?
45.
45. What's 45 divided by 5?
45 divided by 5 is 9.
9. So we've bought 9 11-cent stamps. 9 5-cent toys.
5-cent toys.
So now, when you said there was 15 more to go, what were you? Why did you think it was 15?
Because we got 5.11 cents.
You got 5.11 cents. Oh, you thought we bought 20 toys, right?
Yeah.
But we didn't buy 20 toys. How many toys did we buy?
Yeah. Oh, and it's 55 and 45 equals $1. So.
Right. So about how many toys did we buy?
5 and 9, 14.
We bought 14 toys. Okay. Good job, sweetie. All right. On to the next one. Okay. Here's the next thing we're going to talk about today. We're going to talk about area. Okay. So we know a little tiny bit about area.
Yeah.
We're going to look at the area of just one of these blocks. And here's a square, and we're going to say this side is 1, and this side is 1.
So it's not actually. It's not actually a square.
Well, this is a square. Well, sorry, you mean it's a cube?
Yeah.
Right, we're going to pretend it's a square.
So we had to flatten it out.
Okay, so flatten it out.
So do it.
Blah, squish. Okay. All right. Now, so we're pretending this cube is a square, and we're gonna learn about something called area today. So we've talked about perimeter. What's the perimeter of that square?
It's 4.
4, right? And the area of a square whose sides are 1, we're gonna call. Let's pretend it's 1 inch. Okay.
So you don't forget.
Okay, I won't forget. The area we're gonna call 1 square inch. 1 square inch, which we write like this: 1 inch, and then a little tiny 2 on top. That's how you write 1 inch squared.
Yeah, sometimes when I do that.
Well, we'll do it later, but that's just how you write it. So the area of 1 square with one inch on each side is called 1 square inch. So now we're going to add up. We're going to learn about how area adds up. So if I have a square that's 2 on each side, two
Inches.
inches. Oh, no.
Squared.
2 inches. What do you think the area of this is going to be?
8. 8, because 2 times 4 is 8.
Well,
8 inch.
how many 1 by 1 squares did we use to make this bigger
4.
square? We used 4. So the area of 1 plus the area of the other one plus the area of the other one plus the area of the other one is 4. Right? So this is 4. So 1 by 1, the area is 1. 2 by 2, the area is 4. What's the perimeter here, by the way?
The perimeter.
What's the perimeter?
Is 8 inches.
8, right? So you go around. So what was the perimeter from the 1 by 1 square?
4. Da.
Okay. So this is interesting. But why don't we look at a 3 by 3 one now, just to see if we can find any patterns? Okay.
I believe the next one. I believe this 3 by 3 is going to be 12.
For what? The area or the perimeter?
Well, along the outside.
Along the outside. Okay.
Yeah, because you see, I see the pattern in the perimeter.
3, 3, 3, 3. Okay. So what's the perimeter here?
Perimeter is 12.
The perimeter is 12. Okay. What's the area? How many 1 by 1 squares did we use?
We used 3 times 3, which is 9.
We used 9. So the area is 9. Do you see a pattern in the area yet?
1, 4, 9.
What do you think the next one's going to be?
Oh, I know that. The next one's going to be 16 over there.
Okay. The perimeter is going to be 16 for a 4 by 4 square. What do you think the area is going to be? Before we write it out, what do you think the area is going to be?
I don't know if it is 4 by 4.
Yeah, it's 4 by 4. Do you have any guesses?
Could it be 14?
Well, how many squares do you think we're going to use to make a 4 by 4? How many 1 by 1 squares are we going to use to make a 4 by 4 square?
Well, that's going to be... So we're probably just going to add another row down there. No, we're going to go around the outside.
Right.
So that's going to take 1, 2, 3, 4, 7.
It's going to take 7 more. So what do you think the area is going to be?
16.
16. Okay, so let's take a look. Let's lift these out of the way. Wah! Okay. And I'll do them over here this way. Okay. Alright, so pretend that's our square.
Which has 16.
So it has 4 here, 4, 4, and 4. Alright, so 4 by 4 is 16. 1 by 1 is 9.
1 by 1 is 1.
1 by 1 is 1, sorry. 2 by 2 is 4. 3 by 3 is 9. 4 by 4 is 16. What do you think the 5
by 5 is 25. These are magic squares.
These are magic squares. So the way you calculate the area of a square is you multiply the length of one side times the length of the other side. And so what would it be? What do you think the area would be for a 10 by 10 square?
100.
100. How about for a 8 by 8 square?
80? No. So 8 is going to be 64.
64, very good. Okay. So now, what if I told you a square had an area of 81? What's the side? How big is each side? If the area is 81, how big is each side?
I don't know.
Well, how do you figure it out? How do you get the area?
You multiply this by that.
Okay. So if the area is 81,
You can do a very good job.
area equals 81, that means x times x equals 81.
X times X.
X, oh sorry, sometimes I write
Dots.
dots for times so you don't get them confused with x's. Big X times big X equals 81. So what's a number that when you multiply it by itself you get 81?
9.
9. So if I told you a square has area 81, that means the side has a length of 9. What if I told you the area of a square was 49?
It would be 7 on each side.
It would be 7 on each side. Okay, very good. So that's our lecture on area. And the homework problems for today are Olympiad 27.
Daddy, you forgot about the perimeter.
Okay. Olympiad 27, problem number 1 and problem number 2. Those are the homework problems for today.
Yep.
All right, those were fun, weren't they?
Yeah.
All right.